Hey friends, so this is our last lesson of this huge unit on functions, and it's our last lesson on this last section on operations with functions, okay? So we're gonna deal with composite functions today. Composite functions, and just to backtrack, the last two lessons we've dealt with adding and subtracting and multiplying and dividing functions together, okay? This one is just a little bit different where we put one function inside another function. Okay, it's still not complicated, but of all the things we do in function ops, this is probably the more complicated part. Okay, but we'll take it nice and slow, and you're going to be awesome at it, so don't stress. Okay, so composite functions are functions formed from two functions, f of x and g of x, where the output of one function is used as the input of the other, and I'm going to show you this in a minute. Okay, so the output of one becomes the input of another. Now, our notation looks like this, and I want to have a quick conversation around this because this is super important. This little guy right here is a non-colored in circle, okay? When you see that non-colored in circle between the F and the G, that refers to composition. Yesterday, we would have talked about this, where I gave you a colored in circle. That refers to multiplication, okay? They are two completely different things. And unfortunately, if I ask you to compose on a test and you multiply, you've done nothing right. Vice versa too, if I ask you to multiply and you compose, you've done nothing right, okay? So you gotta be really careful of the symbol. Make sure you know exactly what's being asked of you, okay? All right, I'm just going to clear that. So that reads as f of g of x, or f composed with g of x. You would usually be given it on a question like that, but I would always write it like this, because this gives you a much better visual as to what you have to tackle in a second here, okay? So even though the question will always give it to you like this, always write it like that. Okay. So given f of x is 4 minus x and g of x is x squared plus 2, determine the following. Determine f of 6. Well, f of 6 just means I'm going to go to my f equation. Wherever I see x, I'm going to replace it with 6. So I've got f of 6 equals 4 minus 6, and that equals negative 2. If I asked you for g of negative 2, I would go here and I would say, okay, I have to replace x with negative 2, so g of negative 2 equals negative 2 all squared minus 2. And that would equal 2, 4 minus 2. So now down here, I'm asking you for g of f of 6. Well, when you have lots of brackets going on, the general rule of thumb is you have to go to the center of the brackets and kind of claw your way out, okay? So the very first thing I want you to see here is you have to figure out what f of 6 is. Well, I know what f of 6 is. I kind of led you down a garden path here. F of 6 is negative 2. So now that I know that f of 6 is negative 2, I can replace my whole f of 6 because I know what f of 6 equals. F of 6 equals negative 2. I can replace my whole f of 6 with negative 2, which means now I'm looking for g of negative 2. Well, hey, I know that too because my math teacher is so kind to me. He already made me do that. G of negative 2 is 2. And so g of f of 6 ends up being 2. Okay? All right, let's try f of g of x and g of f of x. Again, you go to the center of all the brackets and work your way out. So the first thing you're asking yourself is, do I know what g of x is? Well, sure I do. G of x is negative 3x plus 5. So instead of writing g of x, I can write negative 3x plus 5. So now that says f of negative 3x plus 5. Well, this says take the x equation, sorry, I was playing with my mouse at the same time, take the f equation, and replace x with negative 3x plus 5, right? On a previous slide, I said, what's f of 2? And you replaced x with 2. There's no difference here now, except it's a little messier. So here it says f of negative 3x plus 5, so we're going to replace x with negative 3x plus 5. So here's x, x gets replaced with negative 3x plus 5. So that's going to look like negative 3x plus 5 plus 6, because it was originally x plus 6. Are you with me? Okay. Okay, now I just clean that up. I don't actually need the brackets there. They were only there for your visual understanding. So I've got negative 3x plus 11 altogether there. Okay, let's try g of f of x. So now that means I'm always going to the center and working my way out. I need to know what f of x is. Well, I do. F of x is x plus 6. So I can replace my f of x with x plus 6, which means I'm looking for g of x plus 6. That means I go to my g equation, which is negative 3x plus 5. But instead of x, I'm going to replace x with x plus 6. So that's going to give me negative 3, x plus 6 plus 5. Now I clean it up. The negative 3 gets distributed. So negative 3x, negative 18, and then negative 18 plus 5 gives me that negative 13. Okay? That's really all we're doing today. Okay? So once you kind of unpack, well, that was a sort of lie. I have to deal with domain too. But once you kind of unpack what we're doing, I'm hoping that it's going to feel very comfortable to you. Okay, so does f of g of x equal g of f of x? And the answer to that, looking at this, is obviously no, which means the order is important. You have to pay attention to what order you're working in, okay? All right, so given f of 2 equals 2x plus 6 and g of x is x plus 8, determine the following. So we're going to do f of g of 2. Again, you start at the center. The first thing you're asking yourself is what is g of 2? Well, g of 2 is 10, because when I plug in 2 here, I get out 10. So now I'm looking for f of 10. Okay, now that I know that I'm looking for f of 10, I go to my f equation, and I'm going to say plug in 10 for x. So I've got 2 times 10 plus 6, and that's going to give me 26. Okay, so f of g of 2 is 26. Okay, now you try g of f of 4. Well, the first thing I'm asking myself is what's f of 4? So I go to here, I plug in 4. 2 times 4 is 8 plus 6 is 14. So now I'm looking for g of 14. All I did there was I figured out what f of 4 is. I just did it inside those brackets. Okay, now I'm looking for g of 14. I plug 14 in for x to my g equation, and that gives me 22. Okay, so again, that means g of f of 4 is 22. I gotta pay attention to what I'm saying here. Okay, then g of 0, let's try that. So the first thing you're doing is finding g of 0. G of 0 is 8. So now I'm looking for g of 8, because g of 0 is 8. Do you hear what I'm saying there? I just really want to make that clear, because if you can click on what's happening, this is not complicated anymore. Now I'm looking for g of 8. G of 8 is 16, because when I plug in 8 to g of x, I get 16. Okay? Okay, so now, very similar process. The only difference here is that I'm reading them from bubble diagrams. Okay, so I don't know how much comfortability you have with bubble diagrams. This represents f of x, so the first bubble would be your input and the second bubble would be your output. And then this represents g of x. Your first bubble would be your input and your second bubble would be your output. So when I read this, I'm essentially seeing input matched to output. So I can see, just before I even look at this question, don't just ignore the f of g of 12 there. 2 would map to 7. So the input of 2 goes to an output of 7. The input of 3 goes to an output of 12. In g of x, the input of 9 goes to an output of 2. The input of 12 goes to an output of 4. Okay? So I'm being asked here, f of g of 12. Now, it's written in that composition way. So I want you to rewrite that first. So that says f of g of 12, because that's a better visual. Now I can work from the inside out, and I can say, okay, I need to know what g of 12 is. Well, g of 12 is 4. Do you see what I just did there with my mouse? This is my input. G of 12 is 4. So I know that g of 12 is 4. That means I'm looking for f of 4 now because g of 12 is 4. So now I head over here. F of 4 is 11. So f of g of 12 will be 11. Okay? Let's try g of f of 2. Okay, so again, write it the other way first. G of f of 2. So the first thing I'm trying to figure out is what's f of 2. F of 2 is 7. So now I'm looking for g of 7. G of 7 is 1. So I know that g of f of 2 is 1. Okay? All right. Given f of x equals x minus 3 and g of x equals the root of x, determine the following and state any restrictions. So I've got f of g of x. First thing I want to do there is rewrite it with the brackets. Now, that means I'm looking for g of x first. G of x is the root of x. Okay, so I've replaced g of x with the root of x. I now have a restriction that I want to start talking about, which would be x has to be greater than or equal to 0. I'm going to plug that into my x of f of x up here. So that's going to end up being root of x minus 3. Now, what were the restrictions? Overall, the restrictions were that x has to be greater than or equal to 0. Okay, the restrictions are going to come from the function you're putting in. So I put this function in, okay, and from the function you get out. They won't actually come from the original function you're using to put in because you actually never used that function as it was. You didn't use it until you put the new function in, okay? Okay, g of f of x then, we have, I just rewrote it as g of f of x. Okay, so now f of x is x minus 3. So now we're looking at g of x minus 3. So now I'm going to the g equation and I'm replacing x with x minus 3. That will change the restrictions. There was no restrictions in what I put in, right? So I'm looking at this guy, but there was no restrictions there. And now I'm looking at the output. The restrictions there will be x is greater than 3 or equal to. Okay, so x is greater than or equal to 3. Okay, so we're going to try it again. Now this looks scary because I'm dealing with 3 different functions now. But again, the same thing happens. I just go to the center and I claw my way out. So the very first thing I see here is h of x. I know that h of x is 1 over x. And so I replace my h of x with 1 over x. That's why it now says g of 1 over x, because I know that h of x is 1 over x. So I could just make that substitution. Okay. Currently, I would now have to say x can't be 0 because I have a 0 on the, or because I have an x on the bottom. So now g of 1 over x, I'm going to my g equation and I'm replacing x with 1 over x. Okay, so now I'm looking at the square root of 1 over x. Now that I'm looking at the square root, x also has to be positive. Okay, so x can't be 0, and x has to be positive. So I can say that in one statement just by saying x is greater than 0. Then I'm going to plug this into my f equation, which is x squared. So I'm going to take this and I'm going to square it. And when I square it, that leaves me with just 1 over x. The restrictions that have occurred along the way, though, are still there, okay? So my restriction, see, I had a note there for you. The domain of a composed function depends on the restrictions of the initial function in the composition and any restrictions that occur in determining the final function, okay? So my overall restrictions are still going to be x is greater than 0 there, even though that root has simplified away. Because it existed in the process, I can't have a negative because it would stop that process, okay? Okay, let me clear that ink for you. All right, so now we're gonna try h. Now, this is in the composition, this is written from a composition standpoint. I want you to write it from brackets, okay? So that would be h of g of f of x, okay? H of g of f of x. So that means I'm starting with f of x this time. Okay, so I know that f of x is x squared, so now it's going to be h of g of x squared. No restrictions yet. Okay, now I'm looking at g of x squared, which means I'm going to go here and replace my root x. I'll replace my x with x squared there, so that'll be the root of x squared. Well, the root of x squared is just x, so actually there's still no restrictions here. because I squared the x first, right? If I squared the x first, I'm always going to have a positive number, and so I can root it. I can root anything I want, and it's going to be okay. Then I plug that fella in, so it says h of root of x squared. So now I replace my x in h of x with the root of x squared, and that's going to give me 1 over the root of x squared. Now this simplifies to the exact same thing that it simplified to on the previous slide, but I have different restrictions now because the order of how I did things ended up being different. Okay, the only thing I have to say here is x can't be 0 because I have the x on the bottom of the fraction. Okay, all right, and then we're going to try g of f of h of x. Okay, g of f of h of x. So h of x is in the middle, so this is going to be f of 1 of x. F of 1 over x. Okay, now restrictions so far, x can't be 0. This guy, f of 1 over x, means I'm heading over here and I'm going to square it. Okay, so f of 1 over x will be 1 over x squared. Now I'm looking for g of 1 over x squared. Well, that means I put 1 over x squared into my g of x. So that'll be the root of 1 over x squared. Now, interestingly enough, I still get, as a final answer, when I simplify it, 1 over x. Okay, so this is just how these equations work. That won't always happen because we've already talked about the fact that changing the order could produce a different result. And in fact, it does produce a different result here because it produces different restrictions. Okay, so in this one, what were my overall restrictions? Well, I don't actually have to worry about the root sign here because I've already squared that number before I took the root. So the only restriction on this guy is the x can't be 0. Okay. Okay. Given the domain, f of x equals x minus 4, root of x minus 4, sorry, and g of x is 3x plus 1, determine h of x if h of x is f composed with g of x, and state the domain. Okay, so really, it's the same question as the last one I just gave you. It's just two different functions now. So h of x is f composed with g of x. Okay, so g of x is 3x plus 1, so I'm saying it's f of 3x plus 1. Okay, so now f of 3x plus 1, I'm going to plug 3x plus 1 into the x of f. I don't know if you, I think you can see me circling there, yeah? Okay, so that's going to equal the root of 3x plus 1 minus 4. Now I'll clean that up. That would be 3x minus 3. Okay, so my restrictions on the domain, if I have to give my domain, I need to think about all the restrictions that have happened, right? The restrictions come from what I input and what I get out. They don't come from this original f of x because I actually never used it, right? The very first time I see that equation, I have already inputted 3x plus 1 there. Okay? I've seen this come up on a diploma. That's why I'm stopping and just, I want to make sure you understand what I'm saying. So the input for your domain comes from, sorry, the restrictions for your domain come from the original equation you're inputting and the final equation you get out. Okay, so there are no restrictions on 3x plus 1. On this guy, we do have restrictions. Bring the 3 over, and you would say x has to be greater than or equal to 1. Okay, so my domain becomes the restrictions. All the values of x such that x is greater than or equal to 1. Okay. Okay, let's try this guy then. Assume f of x is the root of x minus 3. G of x is x squared over x squared minus 9. Determine the domain of h of x equals g composed with f of x. Okay, so I'm looking at g composed with f of x this time. That means I'm looking at g of the root of x minus 3. Okay, so g of the root of x minus 3. Now, I have restrictions there. That's the function I'm inputting, so x does have to be greater than 3. Okay, so that will come into play in a minute. But for a second, I'm going to plug that into my g of x equation. So I have root of x minus 3 squared over root of x minus 3 squared minus 9. Now, root of x minus 3 squared is just x minus 3. But that doesn't mean the restrictions go away because that was part of what I was inputting, okay? So at some point, the root of x minus 3 exists in this graph, even if it simplifies out. So the restrictions don't go away here. And then this guy down here will be x minus 3 minus 9. So when I simplify that out, negative 3 minus 9 is negative 12. So my simple version is x minus 3, x plus 12, and now I have to think about restrictions. So I've already talked about this guy, x has to be greater than 3. Down here, I also care about x can't be 12. Now, do I need to say both of those statements? Yes, because 12 exists in the x is greater than 3. Okay, so because 12 creates a more restrictive domain, I have to say it. Okay, if that was x can't be negative 10, I don't need to say that anymore because I've already said x is greater than 3, right? So there's no purpose in saying x can't be negative 10 when I've already said x is greater than 3. So there, I would just say, essentially, you have to say the most simplest restriction possible. In this one, x is greater than 3, but can't be 12 is what I have to say there because the x is greater than 3 didn't account for the can't be 12. Okay? So my domain ends up being x is greater than 3, but x can't be 12, and x is a member of the reals. Okay? Awesome. Okay, so again, just to make sure you're cool with this, the domain of a composed function depends on the restrictions on the initial function in the composition. So the one I'm putting in, and any restrictions that are in the final function, okay? All right, so given f of x is x squared minus 2, and g of x is 4x minus 1, sketch the graph of y equals f of g of x. Well, let's figure out what f of g of x is first. So that would be f of 4x minus 1, which means 4x minus 1 is going up in here as a replacement for my x. So I have 4x minus 1 squared minus 2. Now I'm just going to clean that up a bit. That'll be 16x squared minus 8x plus 1. And then 1 minus 2 gives me that negative 1. So I just did that all in one step. Okay, so go ahead and graph that, and we'll get the domain and range of that. I'm assuming you're pausing. Okay, so the domain is x is a member of the reals. I have a quadratic there. And then the range will be y is greater than whatever that minimum point is. And when you calculate it, you should get negative 2. So x is a member of the reals for the domain. And the range is y is greater than or equal to negative 2. Y is also a member of the reals. Okay. All right, try this guy. Now we're going to do g composed with f of x. Okay, g composed with f of x. So that would be g of x squared minus 2. So that's going to be 4 times x squared minus 2, and then subtract 1. And now I'll just distribute the 4. So that's 4x squared minus 8 and minus 1. So that'd be 4x squared minus 9. Okay, go ahead and graph that guy now and get the domain and range. So that's what she looks like. And the domain will be real. The range will be greater than or equal to negative 9. Okay. So again, just getting comfortable with what the new function looks like and being able to describe the new function in terms of domain and range. Okay. All right, so that's it for today. Your homework is posted there. Have a look through it. Again, make sure you're communicating super clearly. And if you have any questions, come find me, okay? So this is finishing up this unit. Next, we start trig, which I'm so excited about. Trig is like my favorite. But until then, concentrate on this, okay? Take care, guys.